said, stay on track. Watch your back. 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 Stay on track. Ooh, watch your back. Looking around you and thinking it's okay. Forgetting about the things that you did yesterday. But oh, if you only knew that the game isn't played that way.
What is public?
Yeah, sometimes our friends will snoop around, get the URL for the live, and they will hear us talk before it. All right, I shall start the countdown. 15.
Ooh.
10. 5, 4, 3. Import episode 48. It's 8 July 2017, streaming directly from Singapore. It's Webuild Live.
This time on Webuild Live, we'll be chatting about Scala programming language with Haoyi.
Yay! Welcome to episode 48 of Webuild Live. I'm your host, Sayani, and on the soundboard is Chinmay. And our guest today is Lee Haoyi. Good morning, Haoyi.
Hello.
All right, so we got to know Haoyi because he just tweets and shares a lot about Scala.
Yeah,
A lot about Scala. And he has...
We also heard him talk at the NUS Hackers a
Oh,
couple
yes,
of times.
that's the first time he had a general talk about how to debug or like get into the code base of any unknown open source project.
That was a really nice talk.
Yeah. And that's how we got to know Haoyi through NUS Hackers. And then we just saw that he was just sharing a lot. And if you don't already know, please check out his blog while we get through this live podcast, leehaoyi.com, and also his open source projects, which are mostly listed on github.com/leehaoyi. So we are here to talk about Scala, about open source, about anything that Haoyi's hacking on, coding. So Haoyi, why don't you introduce yourself?
Oh, hello everyone. So I'm Haoyi. I'm a software engineer. I'm currently based in Singapore. Previously, I've worked at Dropbox and other places, and I've done a lot of work open source around the Scala programming language. So that's been kind of a hobby of mine with many side projects that over the years have been used by a number of people. And I guess I like it enough that I keep working on it despite the fact that it's not really making any money. It's just a hobby.
Which reminds me, Patreon, right? Haoyi, you're on Patreon.
Yeah.
So yeah, if you like his open source projects, if you use it, contribute on Patreon. Okay, great. So audience, thank you for joining us on a live Saturday morning. We'll be talking a lot about Scala, about open source and Haoyi's projects. And if you have any questions for Haoyi on Scala, please drop it on gitter.im/webuildsg/live and we will pick it up and Haoyi will answer them. So Haoyi, why don't we dive straight into what is...
Oh wait, don't you forget the malformed query.
We did. We usually have a welcome gift for a guest.
Yes, we do.
Yes.
So at the beginning of every show, we welcome all our guests with what we call a malformed query. So a malformed query is sort of a question that I'll ask you, Haoyi, which you can kind of answer if you want. It's more like a pun or a riddle. So your malformed query is, what did the array say after it was extended? What did the array say after it was extended?
Array.
In JavaScript, they would say undefined.
Well, this one said, stop objectifying me.
Oh my God.
That's a good one.
Well, now that everybody is awake, let's move on to our real topic of the day, which is Scala programming language.
Okay, all right. So Haoyi, why don't you tell us what is Scala programming language?
Sure. So Scala is a relatively new programming language. I think it came out a bit over 10 years ago, which is quite young in programming language terms.
True.
So it's a kind of a mix of an object-oriented language like Java and a functional language like OCaml or Haskell. Mm-hmm. And it happens to run mostly nowadays on the Java virtual machine. Although now there's also the backend which runs on JavaScript called Scala.js.
Right.
So people have traditionally used it for a lot of things, but mostly around either compilers or distributed systems or websites. And it's quite a broadly used as far as niche languages go.
Okay. It's very interesting because when I looked into this, right, I saw that it had a very strange background. It says, it's both functional and OOP, right? Like, how does it pull it off? Like, that's generally these two camps are considered like, polar opposites, right?
Yeah. So it's a bit unusual in that it's actually in many ways more OOP than Java is, where Java is often considered the canonical OOP language.
Yeah, it is. Yeah.
So you can create objects. Objects have methods. Objects have fields, and you pass objects around. And everything is an object, including things like integers or other primitives that aren't really objects on the underlying runtime, but the language pretends that they're objects, and it works well enough in practice.
Okay.
But it's also functional in that it encourages you to do things. I guess what makes it functional is it encourages you to do things without changing variables. So you define. So the default variable is actually called value, not variable, and value is basically a final variable in Java.
Okay. So it forces everything to be final, so that you wouldn't be able to change it.
Is it the unmutable?
Immutable. So it doesn't quite force you, but it encourages you to make things final, and it provides some nice tools that make it easier. So, for example, like if you program in Java a lot, you often have this thing where you create an object and the object's in this half-baked state, doesn't really work yet, and you have to call a bunch of like setters or builders on the object in order to make it work.
Yep.
And in Scala, you don't need to, because objects can take named parameters and optional parameters. So whereas in Java, you need this builder to say, like, I want to set only these 3 parameters out of the maybe 10 possible parameters. In Scala, you just make them optional, and you no longer need a builder which mutates the object. Now you just set them all at once, and the object is ready and immutable. You can't change it, and often you don't need to.
Interesting. That's very interesting, because immutable, like we were talking about earlier, immutable objects or immutability is a very functional programming concept. But it's interesting that you can actually work quite well in an OOP setting as well.
Yeah. So I guess the way I program Scala, which is different from many other people, people have the whole range of like Java like Scala to Haskell like Scala. The way I program like Scala is basically using it like Java, except the places where Java makes you do silly things due to the language design. In Scala, you often have a better way of doing it. So, for example, in Java, people often don't mark variables as final, even when they could be final, just because it's tedious and verbose and generally a pain to remember to do. Whereas in Scala, calling something a value, which is VAL, is the same amount of verbosity as calling something a variable, which is VAR. Those 2 keywords are both short and the same. So you just use immutable vals whenever it's convenient, and you never have this problem of, it's so verbose, I'm too lazy to do it.
Okay. But if you're going to, I've not really looked into the syntax too closely, but if you're saying if you use syntax like val, so does it also do type guessing kind of things, where you just say it's a val and then it figures out what type it is, or you also have to put your type in?
It does type inference like C#, like C# does, and I guess Java's going to at some point.
True. Yeah, that's what. Was it Java 9 that was going to have that, or?
I think Java 10, so another 5 years maybe. It'll take a while.
Very interesting.
All right, so Haoyi, let's talk about Scala being used in large modern applications. To be honest, I first heard about Scala when Twitter started using it.
Oh yeah, this was a big news back in the day, right?
Because they were using Rails, I think, and they refactored some parts of it into Scala.
Yeah, and it was in the programming community is a big thing, because it's sort of a lot of people were like, this is how we make apps, and then suddenly you realize, there's a whole different world when you need to start scaling.
Then you have Airbnb and Foursquare, like seriously, large modern applications are using Scala. And Haoyi, why do you think Scala is so attractive for this? What are they using it for?
So I think it comes down to a number of different factors. There's no one like magic bullet that makes people want to use Scala, but the factors are things like it's concise. So people like Python and Ruby over things like Java because Java is verbose, Python and Ruby are concise. And Scala is about as concise as Python and Ruby are. Often feels like you're writing a dynamic language in how little code you write to get something done. On the other hand, Scala is also very safe. You have the compiler that helps you check things.
Right.
And this is the flip side. Like people like Java because you have the compiler and it's safer than writing Python or Ruby. If you make a typo, it'll get caught. And Scala is like more like Java and perhaps even safer in some ways. People like Scala because it's relatively performant. So it runs about as fast as Java. And for all that people say about JavaScript being web scale and fast, it's actually about 5 times or 10 times slower than Java is. And Python or Ruby, on the other hand, are about 25, 30, maybe 50 times slower than Java is.
Right.
So Scala is about as fast as Java, maybe 2 or 3 times slower, depending how you write it. But it's actually a big difference in that sometimes you don't need to care about caching anymore because your thing is fast enough already. You don't need to care about parallelism. You don't need to care about distribution. It's just already fast enough. I guess the last 2 things also are related to running on the Java virtual machine is that you get all the Java tools, which are very nice. So things like if I have a server in production somewhere and it's misbehaving, I want to insert a profiler into it from my laptop and see what's taking up all the time. Because it's running a Java virtual machine, I can Google it, find Stack Overflow answers of how to insert a remote profile onto my web server. And it just works. Whereas trying to do the same thing in like Python or Go or like say JavaScript, you can make it work sometimes, but it's often much less standardized and much less common and much more difficult to get working.
Interesting, because it compiles down to JVM bytecode. All the JVM tooling, especially like what you said, profiling and stuff, or enterprise level tooling, can be directly applied to this, right? So you don't have to do almost anything. Yeah,
you don't have to create your whole new Scala tooling. You just use a Java thing and it works great. And the same applies for libraries. So like if you have a small like university homework, maybe you don't care about libraries, but if any big application, you have like weird data formats that some guy wrote. You'll have some weird like third-party service you need to integrate with and some weird SDK that you need to operate with it. And with Scala on the JVM, you can often just use a Java library, and Java has a huge number of libraries.
True.
All sorts of things like you want to read shape files, you want to manipulate Microsoft Office documents, you want to interoperate with MATLAB. All these weird things that you may not need, but not everyone will need all of them, but everyone will probably need some of them and different sums of them. And if you're on Scala, you don't need to write your own like MATLAB interoperation library. Just use the Java one and it works great.
True, yeah. MATLAB is actually mostly in Java, right? The UI at least.
The UI is in Java, and the underlying is all sorts of high performance stuff.
I don't know, Fortran or
possibly. I'm not. I won't be surprised if it is some Fortran packages at the back, Blast and all that stuff. Interesting. No, one of the things you said that was really interesting to me was Java gets a lot of shit, for lack of a better term, in the programming world for being verbose and hard to write and slow. And I'm guessing the slow mainly comes from the fact that JVM is slow to start.
Yes,
but when I start looking at people who are doing really high performance stuff or talking to people who are doing stuff where it's very critical to be super high performance, I see a lot of people going back to Java or at least JVM based stuff.
Yeah, so
which is very interesting to me because I feel that I think it gets a lot of bad rap for being like something that's enterprisey and not so cool, but for no reason. Yeah,
well, I guess slow could mean 2 different things. So one is startup performance, and the JVM really does take a long time to start. So for example, I have a small one of the tools I built, the Ammonite REPL in Scala, runs on the JVM, a few megabytes of like executable, and it takes half a second to start. Even before you count actually running the code, the half a second just spent like loading the code into memory before it can start doing things. So you compare it to say Python starts in 30 milliseconds.
Right.
So more than 10 times faster. And if you compare it to something like Bash starts in 4 milliseconds, so 100 times faster. So that's a real problem. But if you're doing kind of back-end systems, maybe it's not that big a problem because the server starts and then hangs around for a while. And once the server warms up, it actually gets really fast. So I think the normal benchmarks typically put it around like 2 times slower than C++ to maybe like 5 times slower than C++ for many things, which is actually really fast.
Yeah, it is. And I see that because of that, there's a lot of this, you kind of like want to talk about REPLs or in-program shells that people tend to use a lot because they don't want to keep restarting JVMs.
Yeah.
I see this a lot in the Java world. I've never seen this so much in the other programming languages. Mm-hmm. Right. But that's very interesting. So other than that, are there any other things we missed out about what makes Scala attractive?
I guess that's most of it.
Yeah.
Like, it's just a bunch of different properties, somewhat unrelated, but all quite useful if you're making a big application.
What about like getting people on board? Is it a language that's hard to learn? Because when you're looking at big teams, one of the things they always worry about is like, how can I get all my engineers to learn this new framework or new programming language?
I think it's definitely harder to learn than many other languages.
Okay.
And part of the reason it's harder to learn is because it's this hybrid language, both object-oriented and functional. Mm-hmm. And so there's a lot of different ways to do the same thing, which is often problematic. So if you have a team that's writing the very object-oriented side of things, like basically using Scala like Java, and you have a different team that's using Scala like Haskell, they're not going to be able to talk to each other or interact with each other. Well, the code can interact, but the engineers will not be able to understand each other's code because it's so different. It
reminds you of Perl, It's like people write Perl, but everybody writes Perl in a different way. You can never understand each other's Perl.
Yeah. So I think it's somewhat different in that you can usually understand your own Scala because you write it in a certain way and that way is reasonable. Whereas you often cannot understand your own Perl, you come back 5 minutes later.
That's true.
Like, it's not just different, but it's also just hard to read. Whereas Scala, what you'd have to do if you wanted to have a team working on it is you have to be pretty strict in saying, this is a kind of Scala we're going to write. So you're not going to be writing that extreme or that extreme. We're going to be writing this point in the spectrum, and we'll just standardize on it just because that's what everyone in our team is going to do, and we can then understand each other's code much more easily.
Are there tools in the Scala ecosystem for doing things like linting or somehow categorizing these kinds of dialects? I would say, I don't know, or however you want to call it.
Not really, but I guess one thing that differentiates things is what libraries you use. So, for example, if you're writing Python, you can basically put in any library and you can expect it to work more or less the same way because everyone writes Python more or less the same way. Or if you're writing Go, for example, everyone writes Go in about the same way, and about the same for Java. On the other hand, for Scala, you basically have the neutral libraries that everyone uses. Then you have the extreme libraries on either end, which if you don't include in your project, you probably won't end up on the extreme. But if you do include those extreme libraries, for example, the more opinionated functional programming libraries,
right,
then you better get everyone in your team on board with it before you include it. You shouldn't just include it as like part of a bigger pull request and hope no one notices. Okay. Yeah.
All right. So now that we know a lot about the good things about Scala and the differences, what is Scala not good for? Like, what doesn't work so well?
Sure. So there's kind of 2 different questions. Mm-hmm. So what doesn't work so well is, for one, we already talked about how you can write a whole bunch of different kinds of Scala in different styles, and that, while some people say it's a plus, it's definitely problematic in practice. Another thing that doesn't work so well is the compiler is really slow. So it's not the slowest compiler in the world. I think, like, for example, the SCSS compiler is slower, and the Rust compiler is sometimes slower, and the Google Web Toolkit compiler is sometimes slower.
Okay.
But it still is definitely on the pretty slow side of compilation, and it doesn't work for the same kinds of workflows that you do with Python or Ruby. So, for example, if you're writing Python or Ruby code, you'll be running the code over and over and seeing the behavior at runtime and deciding how you want to change the code to make it behave. Mm-hmm. Whereas with Scala, you can't do that because every time you run it, it's going to be like at least 1 or 2 seconds just to get it compiled before it starts running. Mm. So you end up with a different workflow where you have to think a bit more before you run the code. And the language helps you. So, for example, rather than running the code to see what type of variable is, you can just ask your editor, hey, what type is this? And it'll tell you.
That's interesting.
Rather than running your code to see, did I pass in the right number of functions? You just type it in and wait for the editor to tell you, did you pass in the right number of functions? Otherwise, it'll give you like a red squiggly underline. Right. So you have to change your workflow to get around the slow compilation. And it works okay, but definitely is a downside compared to something like Python, where you just like splat out the code and run it, and it instantly does what you want or not. I guess the last thing is that some of the tooling surrounding Scala is confusing. So, for example, Scala has a number of IDEs, but they don't generally work as well as Java IDEs. Like Java IDEs really spoil you because they're so perfect. Everything works perfectly. Everything is so tightly integrated. Whereas Scala IDEs are a bit more like Python IDEs. So if you've used like PyCharm, for example, or you've used like Wing IDE, or it generally works maybe like 80% of the time, and the other 20% it just can't figure out your code or doesn't work for some reason. And it's still very helpful. I use PyCharm a lot at Dropbox, and many others do, but it won't give you the polished, super integrated experience that a Java IDE may give you.
In fact, Haoyi, you also wrote a blog post which is more on the technicalities of Scala programming language, warts of the Scala programming language. So if you have a chance, go read through it. He actually talks about the language structure and the properties in the language and goes through the warts of it. So that's another take on Scala programming language.
So that blog post basically covers many of the more small, low-level things, like this piece of syntax is annoying unnecessarily, or that piece of syntax is error-prone. So I think Scala has many of these, like many other languages. And that, I guess the hope in writing that blog post is that eventually you can build consensus and try and get them fixed.
Right. How does it work with the community? Is it the community driven like language decisions and stuff like that, or?
I guess it's not quite fully community driven. So if I were to describe it, it would be kind of like an oligarchy.
Sure.
So it's not one person in charge of the whole everything, but it's a small number of big organizations who have the most say in where the language is going. So you have the university, which first created Scala. I think that's EPFL in Switzerland. They're one big party. You have TypeSafe, which is a company that works on Scala commercially, now called Lightband, I think. And you have a few other like big parties who have most of the mind share and who have most of the say in where the language is going.
Right.
So if you're like a random person using Scala, you probably won't be like, it's not like many others like Rust where they have, or Python where you have big open like votes and stuff on whether you want to include language features. But there is a general consensus process where the big parties will try and find a consensus among themselves. It's generally will work for them, and if it works for them, it'll generally work for most people because they're pretty disparate. Like, one's an academic lab and one's a company, and others are like product companies using Scala for other things.
Right.
Yeah.
That's a different point of view.
But there is always a lot of conversation about this, and they're open with hearing at least your views.
So when you write a blog post like what you did, you can kind of get this word to them.
Yeah. So like me writing the blog post, I don't get a vote, but if I can get them to listen, then these guys, also because they are the ones doing all the work. So since they're doing all the work, you try and get them to believe what's worth working on, and then hopefully they'll do it.
Right. Okay, it's interesting to always know how language standards and are built for the next version. So the next segment, we are going to be talking about tools for Scala, and that's going to be a big segment, I think. So audience, if you're listening to us, drop questions for Haoyi, which we already have a few.
We have a few questions already.
But if you have more questions, just drop them in the gitter.im/webuild.sg/live, and we will pick it up for Haoyi later. So let's talk about tools. What are the common tools that you use every day in your development?
Sure. So the most common IDE everyone uses is IntelliJ.
Really? Okay.
Yeah. So I think it's
like Java.
So IntelliJ supports Java. It supports Python, Ruby, PHP, JavaScript, like basically almost every language under the sun, and it also supports Scala. And within the Scala community, IntelliJ is definitely the most popular choice. I think at conferences, they often have these surveys of what tools you use, and IntelliJ is usually something like 60 to 70%. So it's quite a large number.
So for IntelliJ, it's a plugin for the Java IDE, right? As Scala, or is it a separate IDE?
It's a plugin, but there's no real distinction in IntelliJ. Like the Python plugin and the Python IDE are basically the same thing.
Oh, really? Okay.
Yeah.
Okay.
So apart from the 60-70% using IntelliJ, if I remember correctly, the rest is split pretty evenly between people using Eclipse, people using Sublime, people using Vim and Emacs, people using Atom. So they all have Scala support to varying degrees, and there are people using all of them, just as not as many. So that's as far as IDEs go. As far as build tools go, basically everyone uses SBT, which used to be called the simple build tool, but people realized it wasn't so simple, so it's been renamed to the Scala build tool. So that's, I guess, an ongoing pain point in the Scala community because it's somewhat slow and it's very confusing. So there are people working on trying to make that better, but it's taking quite a while. So that's equivalent of, say, Maven in the Java world, or like setup tools in the Python world, or npm and gulp in the JavaScript world. So in Scala, it's called SBT.
Okay.
What about package manager?
So Scala uses the same package system as Java. So there are a number of managers that can work with it. For example, Gradle or Ivy or SBT itself. And there's a new one in Scala called Corsair, which claims to be faster and seems to be pretty good. But generally, the Scala packages are Java packages. Okay. So you publish a Scala packages the same like Sonatype, Maven Central package repositories, and you as a Scala programmer can pull down Java packages basically trivially. And in the same way, a Java programmer can pull down Scala packages if they wish to do so. Right. So it's the same. There are a bunch of different like front-end tools with the package system, but it's roughly the same package system as any Java programmer would be used to.
Okay.
Right. What about hinting or linting? Do you use something?
As far as linting is concerned, there are a number. So one's called wart remover, which attempts to raise errors if you use certain language constructs in more error-prone ways. There are a few automated code formatters. So there's an old one called Scala Reform and a new one called Scala Format, Scala FMT. That's how it's spelled. And those try to like standardize the formatting of your code, kind of like how Go format will standardize the formatting of Go code. Those, as far as I know, are the most popular ones. There are several other smaller ones that haven't gotten as much usage. Yeah.
All right, so why don't we now talk about the tools that you are building? You are building some Scala-based tools. Let's talk about Ammonite.
Sure.
So Ammonite is used mostly for scripting purpose?
Yeah, so Ammonite is a Scala REPL and a Scala script runner. So the REPL is so Scala has already had a REPL that lets you enter code interactively, and that's used heavily for things like Spark, where you want to explore the code, explore the database, or explore the big data cluster interactively. Okay. So the default Scala REPL is kind of like the default Python REPL. Like type in Python and you get the REPL. It works, but it's not very nice to use. Everything's black and white. There's no code highlighting. There's no history in between REPL sessions.
Oh dear, that must be very painful.
So it's okay, but it could be better. And the Scala REPL by default is in a similar situation. It works, but it can definitely be better. Right. So the Ammonite REPL is kind of like the Scala equivalent to the IPython REPL. So if you use the IPython REPL, you get coloring, you get multi-line editing. If you want to define like a 4-line function, you can go up and down and edit your function. Yep. If you define a value, even if you didn't assign it to a variable, it has an input array and output array. So you can go back and fetch like, what's the result of the computation 3 commands ago, and just fetch it out. It prints the output, so it's nicely formatted in multiple lines of indentation. So that's what Ammonite does for Scala, and I guess it's meant to serve the same purpose in that if you're using the REPL all day, you don't want to be trying to dig through unformatted black and white text. You want it to be nicely laid out for you because computers are good at that, and that's what Ammonite does.
Tell us about your new version of the Ammonite that you just launched, like what features it has.
Sure. So I recently released, I guess, the 1.0.0 version of Ammonite, and it didn't really have any new features that the previous like 0.9 point something versions didn't have. Okay. Basically, it's the same old version, just labeled with 1.0 because it kind of stabilized versus what the old versions were. Right. So the old versions are pretty experimental. So if you use a feature in the wrong way, if you as a programmer made a mistake, it give you like confusing error messages and big stack traces. Some things weren't colored nicely, so it's hard to read. There were some missing features that are very simple to implement that would have made it a lot easier to use. For example, being able to like run a script and automatically rerun the script when you save the file. That kind of really small, like polished things. That's basically what the focus of Ammonite 1.0 was. So all the features are basically the same features that people are used to, like a REPL, a script runner, loading packages from the standard package repositories. But all the small things like making sure error messages are understandable, making the output nicely colored, adding a bunch of small features to make it more convenient to use. That's what 1.0 meant. And I guess 1.0 meant that it's ready for you to use. All this stuff is pretty solid and you don't need to worry about bumping into rough edges when using it.
Cool. What are your future thoughts about the future versions of Ammonite?
Sure. So one major pain point currently is IDE support. So Ammonite, the REPL doesn't need the IDE because the REPL is just a REPL, it runs in your terminal. But it also provides like a script running functionality. So kind of like how you can write Python scripts and run them without a big like project file and IDE like package system. Ammonite also lets you run Scala code just by putting some lines in the script and running it without worrying about like all that setup. It works, but IDEs currently don't understand it. So that means that when you're editing Ammonite scripts in IDE, you lose a bunch of the nice things that Scala that people use Scala for. So things like being able to press dot and have the autocomplete list drop down. Things like having your if you import something that doesn't exist, having it show up as error message, and if you press tab after half typing a variable name, have it automatically complete it for you.
That's just a REPL way of typing it.
So that works in the REPL, but it doesn't work in scripts. But it does work in normal Scala code because normal Scala code has good IDE integration. The IDE understands your code. So I guess one thing that I want to get working at some point is to make the IDE understand Ammonite scripts. There's no real like theoretical problem behind it. There are no like difficult engineering like algorithms or anything. It's just that I need to get some time to, or find someone who has time to go and like integrate it with all the IntelliJ like internal systems that they use, and integrate it with Eclipse, integrate it with like Visual Studio Code. And it's basically a bunch of plumbing work. Very hard plumbing, but just plumbing. But once I get that working, it'll be very nice editing of scripts in IDE with the same like full IDE support you expect from writing Scala or Java.
All right, cool, nice. Yeah, that sounds like quite a useful thing that developers would want. Let's also talk about, say, using Scala with web programming languages like, say, JavaScript.
What do you want to know about it?
I think you have worked a lot with Scala.js.
So Scala.js is a new backend for the Scala language. So traditionally it compiles to Java bytecode, runs on Java virtual machine. Now it also compiles to JavaScript code, which can run on the browser, you can run Node.js, you can run on your Tessel JavaScript microcontroller if you so desired. So it's actually a bit surprising how well it works. The code generated is fast, so it runs about 1 to 2 times slower than if you had written the JavaScript yourself, which is often not a big deal. And
so you write your code in Scala, and then it will kind of compile it to JavaScript.
Yes, and then you can run it in the browser. You can access the DOM, the browser DOM.
Okay, so front end as well, as well as back end.
Yeah, and you can access third-party libraries. So I think the most popular front-end framework with Scala.js is React.js, the JavaScript React.js library from Facebook. And many people are using React.js, like jQuery, Moment.js. All the JavaScript libraries are available from Scala.js, as well as many of the Scala libraries that you would use when writing Scala on the JVM.
Interesting. So people have like wrapped around Scala.js around all these libraries, or is there an easy integration or import functionality?
Sure. So I guess there are 3 ways you could use these libraries. One is you could use them raw. So if you use them dynamically, you don't get any type checking and you don't get any editor integration. But you can call any function you want and call any API you want directly, and it just works. It works if you use it correctly, and if you didn't use it correctly, it will fail at runtime. So that's just kind of like it's kind of disappointing coming from Scala, but that's how it works in JavaScript land anyway. Everything just blows up at runtime and you get no editor help. So then the second way of using these third-party libraries is you can define typed stubs. So if you've used TypeScript, for example, you can define .d.ts files, which don't contain the implementation code, but they define like, this function exists. It has these arguments and returns this this like string or list or array of something.
Reminds me of old school C header files.
Yeah, so it's basically the same. And Scala.js also lets you do that. The syntax is pretty similar to the way it works is pretty similar to how the TypeScript header files work, except in Scala instead of TypeScript. And that basically lets you call the JavaScript functions the same way, directly, almost the same syntax as if you had called them dynamically. Mm-hmm. But now that you have these header files, if you make a mistake, it'll get a compile error. And and it also means that you get like editor integration, like if you press dot, you can see the list of functions you can call. You can press tab to autocomplete things, then all the things you'd expect from normal Scala code. And then there's a third layer that sometimes people will go to, is that to wrap a JavaScript library in a more Scala-friendly like wrapper. So this is totally optional, but for example, many things that you do in JavaScript, you'd have a slightly different way of doing in Scala.
Indeed.
For example, in JavaScript, you use ES6 promises maybe for asynchronous return values. In Scala, you'd use a class called Scala concurrent.future, which is basically the same thing, but that's just the way people do it in Scala land. Sure. So people would take third-party libraries and wrap it to make it more idiomatic Scala. Gotcha. Or for example, in JavaScript, people return nulls or undefineds if something doesn't exist. Yeah. And in Scala, people prefer to return optional class, the way it is in Java 8. So in that way, rather than so you don't need to do this. You could always use a JavaScript library as if you'd use it from JavaScript. But if you're using the library a lot, or if many people are using the library, which is the case, for example, for React.js, then often someone will go and wrap in a more Scala-friendly wrapper to make it fit in better with your Scala code. Right. But if you really want to, for example, maybe there's a new function that hasn't been wrapped yet, you can always just call it directly, dynamically, and bypass all this wrapping.
Gotcha. All right.
That was a lot about Scala. Now, before we go on to the last question, audience, if you have any questions for Haoyi, drop them onto the live chat, gitter.im/webuild.sg/live. So Haoyi, one last question on Scala before we go on to the audience question.
Sure.
What is the future of Scala that you're excited about? Any upcoming features, tools?
So there's a few. Probably the biggest improvement that people are working on is speeding up the compiler. So that's definitely the number one pain point everyone complains about when using Scala. And I think the latest snapshot version of Scala has something like a 20% speed up, which is quite substantial. Like it means if something took 5 seconds, it now takes 4 seconds. And that's great if you're running the same code, like compiling over and over throughout your workday.
Do you know how they did it in the compiler code?
It was a lot of hard work and profiling and experiments to see if things make things faster. Yeah. So often it's not very obvious why things are slow, because like performance isn't just how much code you run, but how you run it. So
that's true.
For example, like if you run a bunch of code that creates and destroys objects very quickly, that runs faster than if you run a bunch of code that creates a lot of objects first and destroys them all later, because of like memory and cache performance. So that's kind of often very unintuitive because you're running the exact same code, creating the same objects and destroying them. But in the end, the code just runs at different speed, and it's often not clear why. So my impression is that the core Scala team has spent a lot of effort building up benchmarking infrastructure and running all sorts of these experiments to see like empirically, if I shuffle this around, will it behave faster? Or like where are the actual places which are causing my code to take a long time? So that's performance. In terms of the language itself, there's a new version of Scala coming out eventually. It's not clear exactly when yet, but they're calling it Scala 3 provisionally. And codenamed Dotty due to some like clever pun on one of the implementation details. But so that version of Scala is meant to clean up a lot of the, the cruft that's accumulated in the Scala language. So like many parts of the language have kind of evolved over the years and weren't really designed. So for example, Scala has inbuilt XML support because XML was really popular 10 years ago when Scala came out. Like everything was XML at the time.
True. It wasn't JSON.
And now like everything's JSON, and in 5 years' time it'll be something else. And so in Dotty, they're trying to like get rid of this XML support and replace it with something more general. In Dotty also, the Scala type checker and compiler has also had a lot of weird bugs in it due to how it's evolved. Like many parts of the compiler kind of hack together until it works, but no one really knows why it works. And as a result, it's very hard to debug bugs and you don't know why it works in the first place, or you don't know like if it doesn't work, like or if it's behaving. If it's behaving strangely, you don't know whether it's meant to do that or whether it's meant to do something else because you don't actually know what it's meant to do.
Right.
So Dotty is a complete rewrite that I guess is actually designed rather than evolved. So they have a good like foundation of like how is a language meant to work, and if something is behaving a certain way, you have a good idea of like, is this a bug or is this just how it's meant to behave? And as a result, they cleaned up like a huge number of bugs in the language. Often more bugs that occur in more like obscure cases that you don't bump into day to day, but still bugs that people will eventually bump into and cause problems. So they've cleaned up all that, or most of that stuff. I guess the last thing that I think is quite interesting is, so Scala has a new native code backend. So Scala compiled to Java bytecode, Scala compiled to JavaScript as of 3 years ago. And there's an experimental new backend that compiles to x86 assembly or ARM assembly or whatever, using the LLVM like backend code generator. So that is quite exciting because it solves some of the big pain points of using Scala in some cases, which is that it takes forever to start and warm up. So rather than taking, say, like 0.3 seconds to start and warm up or 0.5 seconds to start and warm up, they have a bunch of new benchmarks using the new Scala native backend, and it takes 0.001 seconds to start, which is like way better. So steady state is not going to be as fast as the JVM for quite a while, but the startup time makes it so much better with creating like command line tools. You run it, you run some command in the bash shell. You don't have to wait half a second for it to run. You just want it to run instantly. And just like Scala.js, and unlike many other like new languages, Scala native can benefit from like all the Scala libraries which already exist. So like, for example, they've ported the new Scala metaprogramming library to Scala native with basically no changes to the code itself. And the whole thing just runs immediately. And you can imagine like all your Scala like JSON parser, Scala serialization library, Scala HTML generator, Scala like whatever. All this stuff does not need to be recreated. You just like add a flag to your configuration and cross-compile it to Scala native, and it should work out of the box. So I think that's quite exciting because you basically have you get a whole new native programming language, but without all like the bootstrapping, like critical mass problems you get when you're trying to write a new language. Because almost out of the box, you have the critical mass of programmers who know how to write it, books that teach you how to use it, and libraries and ecosystem and tooling of like that you'd want to use when you're actually using this language for real work.
Wow, that sounds really cool.
So I think it's quite exciting, and hopefully they continue pushing it and it ends up in a good place.
Great. So where should Scala programmers, interest people go to check out these conversations happening? Is there some online forum or?
So if you're interested in like helping out with the Scala language itself, I guess first, if you're interested in just learning more about Scala or like asking questions about Scala like as a learner, which many people will be, then there's a user forum called users.scala-lang.org. And that's like I think it's a discourse channel which lets you sign up as a mailing list. And you can go in and ask questions of how to use Scala, why your Scala code is not working, etc. And if you're interested in then like contributing, like you want to help push some library forward, you want to end up helping contribute to the compiler, the native backend, the JavaScript backend, then there's another forum called contributors.scala-lang.org, scala-lang.org. And that's where all like the core team hangs out, which, the other guys working on the various compilers and various core platform libraries. And if you want to ask questions, like suggest suggestions, talk about your new project that you want to get people interested in, that more advanced people who'd be able to contribute rather than just learn, then that's a forum that you want to go to. And each of these projects has its own Gitter channel, typically. So there's like the Scala-native Gitter channel. There's the Scala.js Gitter channel. There's a Scala/Scala Gitter channel. And if you go to the project's GitHub page, it should be easy to find from Google. They usually have a link to the Gitter channel. You can go and ask questions and generally talk to people about it.
All right, great. So, audience, don't worry. We will put in all these links in the show notes.
So you can just go to show notes and check them out.
Check out what's happening in the Scala land. So, Chinmay, that was a lot about Scala programming language.
Yeah, it was great.
We have audience questions, right?
Yes, we have 4 audience questions for now, and more if they come pop in. So let's go to IO polling. All right. So the first audience question is from Eugene, and he says that he's not familiar with Scala, but he wants to know if there is an equivalent to scikit-learn or pandas in Scala side of things, and if he's someone who's familiar with R or Python, can he pick up Scala for doing data analysis and modeling?
So there are equivalents, but they are not nearly as ubiquitous or as popular as the Python equivalents. Mm-hmm. So, as a NumPy replacement, there's a project called ND4J or ND4S. I can't remember what it stands for, but it basically gives you like NumPy style big arrays that are big matrices which are fast and quick to work with.
Okay.
As far as the scikit style libraries, like in terms of neural networks and pandas in terms of data frames, I'm not very familiar with what the equivalents are.
Okay.
So
is it a common use case though? Do people use Scala for these kind of things, or is it not yet?
Yeah, like data modeling and data science stuff.
My impression is that people do use Scala for it, but I'm personally not that familiar with that side of the language. Okay. So a lot of that stuff happens around Spark, which is like the very popular distributed data processing system that people use now. And my impression is that they have all sorts of things for like running regressions or hyperlog whatever computations or deep learning or machine learning algorithms. But I'm not personally that familiar with exactly which libraries are the most popular nowadays.
All right. Okay. Next question is from Mike, and Mike asks, "Are you a fan of the Play framework?"
I think it's the Java Play framework that Mike is talking about.
It's Scala. It's all in Scala.
It's Scala, okay.
So yes. Play framework 1.0 was a Java framework, and then Play with a Scala plugin. And Play framework 2.0 is now a Scala framework with a Java front end for it. Okay. So it can be used on both Java and Scala. Now the internals are all written in Scala because the guys who wrote it became Scala fanboys after using the language.
Okay.
I guess it seems like a nice framework. I've used it a bunch in the past when it was quite new, and it seemed to do what it did on the box. It gives you nice things like live reloading in the browser, nice error messages, error formatting, a bunch of good conventions. I guess if you're making a website using if you're making a website using Scala, the Play framework's a natural thing for you to start with. Okay. And later on, if you want to replace it with your own special web server like HTTP4S or Akka HTTP or something, you can go do that later. And Play frameworks, good defaults, good tutorials, lots of material online, and easy to get going.
So I guess it's like the Rails for Ruby kind of thing.
Yeah, I think like the intention is meant to be like a Rails style experience, but just like way faster and safer.
Of course.
Yeah.
Cool. The next question is interesting. Eugene asks again, and I think the answer, even I might know the answer to this. He says, "I want to replace my shell with a Scala shell. Any recommendations?"
Sure. So,
so he continues with just like how one would use IPython for day-to-day file operations and scripting. I think I might know the answer to that.
Yeah. So, like my Ammonite REPL project has a shell module that lets you use it as a system shell.
There you go, Eugene.
Yeah. So you can ls, you can cd, you can subprocess, you can. Okay. You can start your Python shell from an Ammonite shell. Yeah. You can basically do anything you do in Bash in Ammonite. And there are some trade-offs. The good points are that, for one, using Scala is a much nicer language than using a shell, using Bash. For example,
sure.
Bash is good for trivial things like ls. But let's say I want to ls the files and find the top 10 files of extension.class in terms of sorted by file size. Or I want to list the subfolders in my current folder, and I want to find the top 3 subfolders who have the most number of files recursively within them. So all of these things are kind of tricky for you to do with Bash. Like there's probably a one-line command that does it, but you probably will not remember what that is.
True.
Whereas with the Ammonite shell, using Ammonite as a system shell, you can probably figure out just with a few like for loops or with like a few maps and filters exactly what command you want to run to get these results. So the downsides of the Ammonite shell are things like it's Scala. It takes half a second to start up the first time, and the Scala compiler is slow, so it takes about 2 or 3 seconds for the first command you run, and it takes about a quarter of a second for every subsequent command.
Okay.
So once a command starts running, it can run really quickly. So if you want to run like a gradient descent algorithm in your shell, it will run way faster in the Ammonite shell than in the bash shell. But on the other hand, if you're running like lots of really small commands, just like poke around, that stuff runs slower in Ammonite because of the startup overhead for every command.
All right.
It uses a lot more memory than the bash shell. So I think by default, it will use up to about 400 megabytes of memory per shell instance to run Scala. Because
I'm guessing that's because JVM, right? You need one instance of JVM per shell.
It's not just because JVM. So JVM would probably go down to about 50 megabytes if you're just a JVM. But it's because the Scala compiler is a pig and uses like all your memory and all your CPU. Okay. So I think practically you can probably make the Scala compiler use maybe 300, 200 megabytes, but it's not going to get much lower than that. The Scala compiler is just really big, really heavy, and really resource intensive. Okay. And like this core Scala team is trying to make that better, but that's the state of the world right now.
Okay.
So those are the reasons why you would not want to use use Ammonite Scala as a system shell, and the reasons why you may want to explore using it. Yeah.
Cool. So I guess what you said earlier with like using that as a way to access Spark and poke around data might be actually a very good use case.
Yeah. So if you're using it to poke around like data structures and not your file system, for example, you have like this big like graph data structure that's in memory. That's, for example, maybe your friend graph, or you're interacting with a database, and you already have Scala code to interact with the database from your production environment, and you want to interact with the database from your shell. Then that's the ideal situation for using Ammonite.
Perfect. All right. Thank you for answering all our audience questions. Now let's move on to the next section, which is called picks. So the way we do picks is we go around the table. So I'll start first, and then I'll let Sani do it, and then we'll give you some time to think about it, Haoyi.
Sure.
We pick 1 to 2 things that are interesting to you that you just figured out, just found out, and you would like to recommend to our audience to try out. It can be anything. It can be blogs, books, apps, tech, non-tech, or non-tech, even foods, meetups, whatever. So I'll start with something that I've been playing with. It's a small tabletop or benchtop oscilloscope, you want to say. It's like a small little board that I got recently from Kickstarter. Yeah. And it's super handy for doing simple debugging electronics kind of stuff. Mm-hmm. So if you audience want to check out the OpenScope, I will put the links to this show notes.
And the interface, it runs on a browser, right?
That's the coolest thing. Yeah, that was the coolest thing about this was the whole UI for the scope is actually in the browser. Okay. So you have the oscilloscope as a small little piece of hardware, but it doesn't have any screens, and all the UI happens in a browser. I think this is a very interesting
like the hardware world
interface,
having a
web UI. I think this is a very good, interesting direction, and I was super curious to see how well it works. It works all right. I think the web UI is very young, so it'll take a bit of time to move forward. But I think at some point in time, this will be a very cool sort of interaction mechanism. So I'll put the links in the show notes if anybody wants to get it. I think now it's out of Kickstarter. You can actually buy it already.
Okay, it's by Digilent.
It is by Digilent. Yep.
All right, so I have a couple of picks very quickly. One is a breadboard power supply by YW Robot. So, whenever we play with digital hardware, we need either 5 volts or 3.3 volts. And I found this little tiny breadboard power supply, super useful for prototyping my hardware stuff. And my second pick is a book. It's called Deep Work by Cal Newport. I recently read this book, and I felt as a developer or even as any creative people, knowing how to do deep work, like really concentrated deep work for 3 to 4 hours is super important. And this book kind of talks a lot about it. So go and try out Chinmay's OpenScope or the breadboard power supply or even the Deep Work book. Howie, what about you?
Sure. So I guess this isn't really related to tech, but
no, you can't.
It
doesn't matter.
I recently found out that the new East Coast Park to Changi bike cycling route has been reopened. So they were doing a bunch of renovations around Changi Airport because they are doing Terminal 3, Terminal 4, Terminal 5.
Yep.
But it's open again now. So you can start from East Coast and cycle one way to either the Marina Bay Sands, or you can cycle the other way and go all the way past the airport to Changi Village.
Oh, nice.
If you wish, you can cycle all the way back through like Bedok and Tampines and Geylang and end up back at East Coast Park if you want to return your bicycle there.
Yeah.
So that's actually quite fun if you're you're interested in cycling because, for one, the route's really flat because it goes along the ocean, so there aren't any like huge hills or anything. Secondly, it's really scenic and really cool because you have the sea breeze and you're by the ocean. And lastly, it's just a very pleasant, straight. Basically all of it, you don't need to go along the road. Most of it's park connector, so you don't need to be fighting with cars and trucks trying to like survive on the main expressway.
Oh, nice.
Yeah, so if you're free and have a day and you like cycling, you can easily spend like 8 hours. I think last time I took like 6 hours to make one big loop, maybe 30, 40 or up to 70 km around that area. And it's just really nice and really relaxing.
Yeah, this cycling movement is really, really going strong in Singapore, and especially with the park connectors, you can just cycle anywhere. Yeah. I cycle a lot along the Punggol area as well. And by the way, I learned cycling this January.
Yeah, well, I learned cycling when I was 20 years old. So.
Oh, okay, yeah, exactly. So there is no better age to learn cycling than now and try it out, whether you're in Singapore or you're going abroad explore the cities on a cycle. That's a great trip. Thanks, Haoyi.
Yeah, I guess that's it for me. Yeah.
Yeah. Let's talk about the event loops that are happening. All right. We want to talk about slightly about the Singapore Scala programmers. They actually have meetups in Singapore as well. I have not attended it. Haoyi, did you have a chance to attend it?
Yeah, I've been going to it.
Oh, cool.
Yeah.
Cool. So they seem to be pretty regular. They had like 40 over meetups. And so what happens there? Like talks and sharing?
Yeah, usually it's someone talking about their work. And so most of them are, let's see, there's a bunch of small companies using Scala in Singapore, whether like startups or banks using it for Spark or someone trying to implement like a new clever algorithm in Scala.
Oh, cool.
And so people come and share about, these are some techniques I've learned using Scala, or this is some approaches I've done, or these are some tools I've recently gotten experience with. And then people come and talk, and they'll give a talk presenting what they've learned. And people ask questions and talk about, how does that gel with what I've learned? How does that gel with what I want to learn? Like, but does it make sense for me to continue using the tool that you suggested?
Right. So along with the URLs for online links to Scala, go and attend the Singapore Scala Programmers Meetup. And lastly, I also want to mention Maker Faire Singapore. It's happening at the end of this month, the 22nd and 23rd July. So Maker Faire is all about software, hardware, art, science, biology, cooking. It's really a mishmash of ground up kind of an open source, open maker culture meetup. So if you want to check out about this community, I highly recommend you to go to the Science Center. It's happening in Science Center this time.
Yeah, it's happening in Science Center on the 20...
It's on a weekend.
20 and 21st of July.
Yes, that's right. So check it out. Me and Chinmay had the chance to solder some stuff.
Yeah, we were helping out in one of the installations.
Yes,
so we soldered a bunch of boards. So
yes,
you'll see there.
You are guaranteed to find some inspiring projects that are going on there. So go and head down to the Singapore Maker Faire at the end of this month. All right, and the very last segment we have is Electric Plug. Plug. All right, Haoyi, how can people reach out to you?
So I guess I have a GitHub account with my email on it. So if you search Lee Haoyi GitHub, you'll find it and you'll find my email and you can contact me by email. If you're using one of the projects I've worked on, for example, Ammonite or some of my libraries like Fast Parser or Scala Tags, each of those projects has its own Gitter channel. So maybe not even me, but there'll be a bunch of people there who use the project. And if you have questions about those, someone will answer you. And I guess lastly, since this is a plug section, I'll plug my blog.
Yes.
So it's www.lihaoi.com. So I write a bunch of things about Scala, but also about other topics. So I wrote a blog post about about working with Singapore's government data APIs, or a blog post about diving into unfamiliar code bases. So if you're interested in programming or particularly interested in Scala, then it's definitely worth taking a look and having a read.
Yeah.
Cool. Yeah, it was very interesting. I when I started researching for this episode, I did read, and it was a bunch of really cool articles. So highly recommended.
Yes, very, very technical, very long ones, but it's totally worth
it.
Yes,
very long. That's very true.
Yeah, a bit too long probably.
He takes the time to write his blog post.
Yes, definitely. Cool.
Maybe I will also recommend Engineers.SG/presenters. Haoyi also gave a few talks, especially the ones we spoke about. He spoke about Singapore's open data. He has a video on it. There is also the one at the NUS Hackers, the Friday Hacks, diving into other people's code. So if you want to check out Haoyi's videos of talks, this is where you go to. We'll put all the links in the show notes.
Definitely.
Yeah, thank you so much, Haoyi, for
joining
us on a Saturday morning talking about Scala. And we hope the audience got some kick out of it. Like if you're a programmer and you want to just check out another new programming language, Scala is the one.
Yeah, definitely.
Yeah.
Absolutely.
All right. Thank you, Haoyi, so much.
Cool. Thanks.
That's it for this episode 48 of Webuild Live. We will get together again online on another Saturday morning with another cool guest. Until then, return zero.